Hello friends, this is Fahad from Game Code Bytes. In this presentation, we're going to continue what we started with the first episode of grid-based system with JavaScript. But instead, we will have a character that moves on the grid system using the keyboard. So let's get started. As I mentioned before, I'm going to use the same code base I used for the first episode of grid-based system. Now we need to create a player object. So I'll say this dot player equals, we need X and Y and maybe color. Now let's just think through this and see, how do you want to pass the player? Do we want to pass the player as, probably just pass the X and Y position of the player, or we just need to upgrade or actually update the grid matrix with a specific value. For example, 2 is going to represent the player. How do you want to approach this? Now, there are tons of ways to do it, tons of ways to do this. But let's just go with the approach of passing the X and Y position of the player once we initialize the grid system. So I'm just going to pass 1 and 1. And now we need to think through the X and Y position of the player in a different way of what we were doing with the other games we built or other simulations. Now, when you say 1 and 1, that means row 1 and column 1. When we say 2, 2, that means it's going to be here because 0, 1, 2, 0, 1, 2, so it's going to be here. This is the only difference in the coordinate system. Now we need to pass this here. So I'll say player X, player Y, and we need to update this here. Player Y. There are probably tons of ways to optimize this to build a very complicated grid-based system, but this is probably one of the easiest approaches we can do here to explain the grid system in a more simple way, let's say. Next, we need to check what cell value we have, so then we can render the relevant cell color. So we'll do a little bit of refactoring here. We probably can use switch case, and you can do it whatever you want. I'll just use if statement. But before that, we want to grab the cell value. And the cell value is going to be this dot matrix of row, column, and then here we're just going to pass a color variable. And the color variable, we're going to create it here. Color equals, let's just set the default to almost black. And then we'll do if statement. If cell value equals, let's say 1, that means it's a solid, and we can just say color equals like blue. Else if cell value equals 2, and we're just going to use number 2 as a representation of the player on the grid system. Then the color is going to be the player.color. Now again, probably we can create a mapping system, and based on that we can select if this is a player or this is grid or this is solid or whatever we want. But we'll just go with the easiest way to do this. Now let's save this and see. We're not seeing anything, so let's just open the console log. We don't have errors. This is good. Okay. Now we're not seeing anything because we did not update the grid matrix. Because this grid matrix has to have a value for the player, and we don't have, for example, a 2 value yet. And to do that, we can just say this dot matrix of player row, or actually player Y, because we start with the row, and then player X, which is the column, equals 2. And we have a problem here. It's not working. So let's see what's going on. Okay, this is the issue. We need to access the player using this. Good. Now let's start moving the player. So maybe in the constructor, we can just say this dot add. Actually, let's use document dot add event listener. It's going to be key down, and we can create another method here saying move player, and then we're going to call the move player here, move player. And of course we need this. Now let's just make a simple console log moving the player to make sure the listener was successfully registered. Good. Now let's remove the console log. Okay. Now we should be able to have access to the key code here. So key code, we just need the key code from the event. And we'll say if key code equals 37, that means it's left. Else, if it's 39, I think it means right. And I think the down arrow is going to be, the up arrow is going to be 38. And the down arrow is going to be 40. Okay. Now, what do we need to do here? Based on the current position of the player, we want to make sure if the player next move is not going to be a solid cell. For example, here, we're only allowed to move right and down. Left and up is not allowed because these are solid cells. Now you can probably start with the right direction to move the player to the right, but of course we need to make sure that the cell to the right is not solid. It should be empty. And to do that, let's say if this dot matrix of this dot player dot x and this dot player dot y and this dot player dot x, because we start with the row and then the column, and actually this should be +1 equals 0. That means we can move. Now if we run this, we're going to have issues with the scope of this method, and either we make some kind of a bind to fix this issue with the this keyword here, or we can just convert this to arrow function. Okay, we have error here. Let's see what's going on. Unexpected token 19. Oh, of course, because. Okay, good. Now the logic is going to be like this. If the cell to the right is empty, then we need to set this cell value to 2, which is the representation, the numeric representation of the player to be rendered on the grid. So we will set this to 2, and then we need to clear this out and put it to 0. So we will say this dot matrix of this dot player, and we will refactor this later on. I'm just trying to show you the way to do this directly. This is going to equal 0, and then we can copy this and we'll say +1 equals 2. Now let's try this out. Now what we need to do is to re-render one more time, because we updated the matrix, and then we need to say this.render. Now let's try to move the character, and it's moving. Okay. Now if we try to move to the right, it's not going to work because this value is 1. It's a solid. Now there are a lot of refactoring can be done here. And one of those is something I mentioned before, which is the top canvas we draw, which is kind of like a surface or shallow canvas to be rendered over this canvas. And the idea behind the top canvas is that you will keep re-rendering this canvas because it will be responsible for drawing things that need to be drawn more frequently. So we can either do that, or we can just, every time we move the player, we just re-render one more time, and we don't have to use the top context or top canvas anymore. It doesn't matter. Now, before we decide if we want to use the top context or not by just re-render this every time we move the player, which is, it's not a bad idea as well. Let's just create a method, a private method that will be responsible to tell us if the next move is valid instead of all of this redundant code. So I'll say is valid move, and we are going to pass the X and Y we want to verify if it's valid or not. And here we will say if this dot matrix, this dot player dot y plus x is equals 0, then return true. Otherwise, return false. Actually, this should be true, which means it is valid. We can move. Otherwise, returns false. Now let's refactor this. Well, I'm just going to create the logic here, and then I'll delete it so I can see what is going on exactly. So I'll say is valid move, and let's say I want to make sure on the right. So x is going to be 1, which means plus 1 is going to be here. And I don't want to check on the y-axis. If it's valid, then I want to set the value. We can use all of this logic here. And then this dot render. Let us at least see if this is going to work. And it is not, because I am not calling this with a pound. Oh, okay, so we also need to make sure this is private. And it's working. Okay. Now we can probably also do some refactoring here, but it doesn't matter. Let's just move on and make another if statement here. Is valid move, let's see on the left, and this is going to be -1. And this should be minus, and then we render as well. Now what I did, it doesn't make sense. I put the other if statement within the same key code, and that doesn't make sense for sure. This is going to be to the right. Actually, this should be to the left, and this is the left logic here. Okay, this should work now. Let's try it out. And it's working. Now we need to verify on the y-axis as well, on the rows. So here, instead of passing the x value, I'm going to pass, let's say, to the top. If it's valid, then we need to Actually, this is not to the top. It's going to be, I'm not sure if this is the 38. Let's just make sure. What is the 38? Is it top or bottom? I forgot. Okay, so it's top. Good. So that means we need to pass -1. And then this is going to be -1. No, this should be y. We just clear this out. And this should be -1 is going to be 2. And then we'll update this to be -- as well, because we're updating the row of the player, which is the y of the player, to move it to the top. And we can do the same here. But here, instead of passing -1, we'll pass 1. And this should be plus. And also this should be plus. Now we should have a complete movement system for the player. And it's working. And you can't go right or left. I mean, right or left if there are solid cells. Good. I also don't like to have more redundancy here, so we can just create a method in this class, a private method in this class, to clear the value of the current cell and then update the next cell to have the cell value of the player. So let's just create another one and call it update matrix. And we're going to pass the X and Y row and column in which we want to clear. And then also we need to specify what is the next cell we want to update to be 2. And also we can do something else. We can probably just update the matrix based on the given row and column, and then we just pass the value we want to update. I think this should be more general, and it's good. And here we'll say this dot matrix, and let's just grab one of those logic here. So this dot x, actually I always forgot this. It should be row and column. X is going to be equals to this value. Now here, all we need to do, for example, here we'll say this dot update matrix, and we'll say this dot player dot y and this dot player dot x to equals 0. And next, we'll update this to -1 equals this. I know it sounds similar to what we have, but I think it's more robust to use this like this by having a method within the class to update the values or the cells based on the row and column we just passed. Now we can do the same for the other if statements. I'm going to put it down here, and this is going to be plus. Let's remove this. Instead of accessing the matrix directly, let's just use this. Now let's see if it's still working. Okay, the controller is a little bit messed up now. Let's see what's going on. I think the logic get mixed up here because we're passing x and y. Yes, exactly. This is what's happening. So let's just flip this by using y and x, and it's working. Good. Now, I already mentioned that we can still use the top context here. We created something called top context, which is exactly the context of the top canvas. And the top canvas is going to be a canvas rendered with full transparency over all of the other canvases. And the idea behind this canvas is that you are going to draw things that needs to be drawn more frequently. But after some thoughts about this, I think it's good what we're doing here. We don't need that because we're not rendering so many things. If you, like in the future, we want to add more enemies and monitoring system and more players, we can probably start doing that. And the idea behind that is, instead of rendering the player also on the UI, or actually the outline context, we can just render the player on the this.top context. But also we need to do a little bit more logic. We need to create a frame or update method so that we will request animation frame all the time. So request animation frame, and then you keep redrawing things on that canvas. But I think this is just a good way that we structure the code. We have the top context and also we have the outline context, and we have the UI context, and it's ready for you to be used. If you want to, you can just refactor the player to be drawn on the top context and then keep redrawing the player all the time. And we also have this UI context, which is the canvas responsible for updating the UI, things like score or whatever we want to keep track of. And we just put an example here saying grid-based system, but instead you can just create a score text here and then concatenate this text with an integer of score, and every time you do something, you can just update the score based on that. Every time you, for example, you step on a cell with a coin value, for example, you want to render coins on the grid, and those coins are going to have, for example, cell value of 5. So every time you step on value of cell of value 5, you're going to pick up that coin, and once you pick up that coin, you can increase the score, and then you update the UI context for that score text specifically. All right, friends, this is going to be the end of the grid-based system with JavaScript Part 2. What we did specifically here is that we added a character in the grid-based system, and we are able to move that using the keyboard controls. Now, I can create more videos explaining how to add coins and navigating the player from one world to another and things like that. So if you want to see more of those videos on the grid-based system, leave a comment and tell me what exactly you want to see more in the future. Other than that, if you like this video, subscribe to my channel, and thank you guys for watching. This is Fahad from Game Code Bytes.